Hi everyone. Today we will discuss the probability of obtaining a particular sum when a few dice are rolled. So let's consider a couple of unbiased six-sided dice, and let's say we roll them together and we want to see what's the probability of getting the sum as, let's say, 7. So let's try to represent it through a triangular diagram. So we know that the minimum sum appearing combined on both the dice should be 2, corresponding to 2 ones, and the maximum should be 12, corresponding to 2 sixes, right? And then the intermediate sums could also be populated here. Let's say 3, 4, 5, 6. Let's say we have a 7 on the vertex. 8, 9, 10, 11, and of course 12, right? Now we know very well that the number of ways of getting 2 as sum is unique, and that's equal to 1, corresponding to 2 ones on the 2 dice. Same is the case of obtaining the sum as 12, corresponding to 2 sixes, right? So we write 1 in front of each of these. Similarly, we write a 2 here, 3 here, 4 here, 5 here, 6, and basically we take a mirror image on this side. So this is also 5, this is also 4, this is 3, this is 2, and this is 1, right? And we know that the total number of cases when 2 dice are rolled is nothing but 36, right? So from this diagram, this is basically a representation, right, and not in a method in itself, which we'll come to later on. So if I were to say what's the probability of getting the sum as 7, then what we need to do is we have a 6 in front of 7 divided by total number of ways, 36, which is 1 by 6. Let's say we were asked what's the probability of getting a sum as 4. We would see what's the number in front of 4. We see that it's 3. So 3 by 36 is nothing but 1 by 12, which in other words mean that probability of getting a 4 is almost 1/2 of getting the probability of sum as 7, which in other words means that 7 occurs as a sum more frequently than 4. In fact, for the matter of fact, 7 occurs as the sum of the 2 die maximum number of time. Let's see what's the probability of getting the sum as 10. We see that, or let's say, yeah, so what's the probability of getting the sum as 10? So we have a 3 in front of 10, and then we have 3 by 36, which is the same as 1 by 12. Now if you note, P of S4 is the same as P of S10. A keen observation shows here that if you see 2 plus 12 is 14, 3 plus 11 is 14, 4 plus 10 is 14, so on and so forth. The probability of getting the sum as S is the same as probability of getting the sum as 14 minus S. So probability of getting the sum as 2 was the same as probability of getting the sum as 12, so on and so forth, right? Now another thing is that how do we get these numbers 1, 2, 3, 4, 5, 6? Where do we source this from, right? This is just a representation to use it directly, maybe as a shortcut, but where are we sourcing these numbers from? Let's have a look. Seeing a particular sum, for example, let's set on with the sum as 7. Let's say we want the sum as 7. So basically what we are saying is we have a function that goes like this: x to the power 1 corresponding to 1 on the face of the die. Then we have x to the power 2, x to the power 3, x to the power 4, x to the power 5, and x to the power 6. All these correspond to each of the faces. There are 6 faces, right? Now we are rolling the die twice, or maybe there are 2 dice, right? And both of them are independent events, right? One has no bearing on the other. There is either a possibility of getting a 1 or 2 or 3 or 4 or 5 or 6, and so we raise this to the power of 2, and the same is the cases with other die as well. And what this problem boils down to is finding the coefficient of x to the power 7. So basically, let me separate this. So basically we are saying that what is the coefficient of x to the power 7 in the expansion of this particular term inside the bracket whole to the power of 2, right? So basically what happens when you take this x common outside the bracket, one thing to note here is that the minimum value that will be shown here on the die face is 1, and the maximum value of the number showing on the dice will be 6. So that's why we are limited in this constraint for the powers, x to the power 1 and x to the power 6. And that's the reason for the constraint. If the dice would have had more more numbers of faces, then we would have more powers. Now, so x can be taken common. So if I take x common, however there is a square here, so x square will come outside. So it's as good as saying what's the power of x to the power 5 in the remaining expression without that x. So 1 plus x plus, we have taken out x, right, which came out in the form of x square, which we reduced from x to the power 7. 7 minus 2 is 5. So this is x square plus x3 plus x4 plus x5. This is whole to the power 2. Now this expression here, right here, this can be written as 1 minus x to the power 6 divided by 1 minus x, right? So let's say we can take that in the numerator with a minus 1. Now this whole to the power 2, so this will be 2 and this will be minus 2, right? Now if we were to find the coefficient of x to the power 5 in this, we know that expansion of this will contain the first term as 1, and then all the terms will be having powers greater than or equal to 6. Powers of x will be greater than or equal to 6. So only the first term is what we are looking at from the first bracket, right? From the first expression. From the second expression, the expansion goes like 1 plus 2c1x plus 3c2x square plus 4c3x cube, so on and so forth, right? And basically we are looking at the coefficient of x to the power 5 when 1 is multiplied with x to the power 5. So if we see x to the power 5 in this expression, if you see here x in this whole expression, the coefficient of x to the power 1 is 2c1, of x square is 3c2. So the coefficient of x to the power n in this kind of an expression will be nothing but n plus 1c n, right? And if we are looking for a coefficient of x to the power 5, it will be nothing but 6c5, which is the same as 6, and that's what we got earlier. We saw that the number of ways of getting the sum as 7 was 6. Similarly, we can find out the other possibilities as well. Let's say, for example, we were looking at x, what's the sum as 5. So basically we would have had this one as 5, right? And then this one would have become x to the power 3, because 5 minus 2 is 3, right? Then we would have looked for the coefficient of x to the power 3, and we know that in this expression it is n plus 1 cn, so it becomes 4c3, which is the same as 4. And if you see here, coefficient of x to the power the sum as 5, how many ways can we get that? In 4 ways. So this is verified from, and this is where we source this result from. The whole triangle is made from, you know, this deduction that we did right here. Thanks a lot for watching this video. We will build up on this particular concept and we'll try to generalize it for any n and any s, which means we can roll n number of dice, unbiased dice, and to get the number of ways of getting a particular sum s, what would be a general formula? You just need to, you know, put the value of n and s, and then you will get the result instantly. That's where we will get at. So let's watch out for the next video.